confirm this is McAllen. Are all the pre-checks looking good? Copy, thank you. Contact start.
Two-way.
We have two-way.
We are getting internet traffic via the Kuiper network, navigating to Amazon.com now.
Andrew is executing the demo. Right on cue, the heavens have opened up a little bit and it is starting to rain significantly harder than it was earlier. Contact is starting now.
We have
Switch
two-way.
over. We have two-way.
All right, confirmed. We have internet access via the Kuiper network, and I am searching for air rocket racers.
Andrew executing the demo.
Page is loaded. I'm adding to my cart and confirmed.
And Andrew just completed the first successful purchase from Amazon.com. Contact start.
Two-way.
We have two-way.
All right, we have internet access via the Kuiper network. Joining the meeting. All right, cool. Flight, this is McAllen.
Go McAllen.
I wanted to let you know that I am joining this time meeting right now via the Kuiper satellites, which are passing over the customer terminals as we speak.
Congratulations on such a huge milestone.
Thank you.
Nice job, team. Now let's go build some more satellites.
Awesome. Thanks, guys. McAllen signing off.
네, 안녕하세요 여러분. 서울 서밋의 첫째 날 기술 트렌드 세션을 찾아주신 여러분들 모두 환영합니다. 저는 AWS에서 하이브리드 엣지 서비스를 담당하고 있는 솔루션즈 아키텍트 강동환입니다. 반갑습니다. 이번 세션에서 저희가 말씀드리려고 하는 내용은 아마존의 저궤도 위성 기반의 광대역 인터넷 서비스인 아마존 프로젝트 카이퍼입니다. 국제전기통신연합 즉 ITU의 2023년 연례 보고서에 의하면 전 세계 인구의 67% 그러니까 약 54억 명이 인터넷을 사용하고 있다고 합니다. 그러면 나머지 33%는 여전히 인터넷을 사용하지 못하고 있다는 이야기가 되겠죠. 아마존 프로젝트 카이퍼의 미션은 아마존이 발사할 3,200여 개의 저궤도 위성을 통해서 지구 전역에 광대역 인터넷 서비스를 제공하는 것입니다. 이를 통해서 디지털 취약계층이라고 불리는 모든 사람들과 지금까지 상상할 수 없었던 다양한 비즈니스를 가능하도록 하는 것이 아마존 프로젝트 카이퍼의 미션입니다. 앞서 보셨던 영상은 2023년 10월에 유나이티드 런치 얼라이언스의 아틀라스 5 로켓에 실려서 발사된 프로젝트 카이퍼의 프로토 플라이트 위성인 카이퍼셋 1과 카이퍼셋 2를 통해서 모든 검증 테스트를 완료했던 장면입니다. 영상에서 보셨듯이 아마존 프라임 비디오를 통해서 4K 비디오를 영상을 시청하시고 아마존닷컴에 주문을 하고 그리고 아마존 차임을 통해서 실시간 비디오 컨퍼런스를 하는 모습들을 보셨을 겁니다. 자, 이를 통해서 지금까지 우리가 상상하지 못했던 그러한 비즈니스를 할 수 있는 기반을 마련하는 것이 아마존 프로젝트 카이퍼의 또 다른 미션이 되겠습니다. 자, 그러면 이제부터는 아마존 프로젝트 카이퍼 팀을 통해서 직접 아마존 프로젝트 카이퍼에 대한 자세한 이야기와 그리고 그 미래에 대해서 들어보도록 하시겠습니다. Please welcome Sasha Gray.
Hello, Seoul. It's really great to be here and share our Kuiper story. Now, you've just seen a very small window into our journey so far at Project Kuiper and how far we've come. It really is amazing what we've achieved. Now, let's look where we are today and where we are headed into the future.
-7 minutes. Status check to proceed with terminal count. Atlas systems, propulsion.
Go.
Hydraulics.
Go.
Centaur systems, propulsion. Go. Pneumatics. Go. LO2.
Go.
LH2.
Go.
Anomaly chief. Go. Launch director.
You have permission to launch.
Proceeding with the count.
3, 2, 1. We have ignition and liftoff.
Parameters continue to look good. We are now moving at 4,000 miles an hour.
Flight software looks nominal. Mechanicals proceeding nominally.
All Kuiper satellites have been deployed successfully.
Congrats, Kuiper.
Now, for those who may be hearing the name Project Kuiper for the first time, Project Kuiper is Amazon's global satellite connectivity network, and our mission is to deliver reliable, fast, and secure connectivity services that consumers and businesses can depend on all around the world. I'm very excited to be standing here today to be able to show you that video and say that just over 2 weeks ago, we successfully launched 27 satellites into space. This is a huge milestone where we have spent 6 years working to build the most advanced and modern communication system in the world. But we're not the first to provide satellite connectivity, but we are the first to do it like this. You may be thinking, what makes Project Kuiper so different? Well, Project Kuiper actually shares the same DNA that has made Amazon a first choice for consumers and AWS a first choice for businesses all around the world. And I'm sure you would have heard us say many times that our mission is to be Earth's most customer-centric company. And at Project Kuiper, we're actually taking the very same approach to business connectivity. We will continue to drive passion and invention and commit to operational excellence. And we'll always look ahead to ensure that we find that next opportunity to change the world. But it's actually through listening to you, our customers, that we actually continue to live up to all of these principles. It's by understanding the complex challenges that many of you are facing and how our team on the ground are going to be able to continue to invent better solutions for you and your customers around the world. We are truly at the start of the next wave of business acceleration through connectivity. And we understand you have many complex problems that you are looking for our support to help solve. Here locally in South Korea, we know that you have very high fiber and 5G density, but we are learning that customers, for their most critical applications, are looking for solutions that can meet business continuity and resilience at a global scale. We are seeing telecommunications providers prioritizing backup connectivity for disaster recovery. Agricultural and manufacturing industries using backhaul for operational efficiency. Construction and shipping companies with sites overseas who are saying leverage IoT and operational technology for vehicle automation. Mining, oil and gas providers who are in remote locations are providing connectivity for crew welfare and to give access to corporate applications. And finally, airlines who are looking to provide in-flight entertainment to deliver a better customer experience via Wi-Fi connectivity. Now, these are just a handful of the use cases that we are working on today with customers, but truly the use cases are infinite. I'm also really excited to share that our reach will span a breadth of segments across global regions. We are looking to support customers with use cases on land, sea, and air, and we are excited to work with businesses from small to medium, through to enterprise, and then all the way through to state, local, and federal government. So how do we achieve all of this? And how does it work, you may ask? Firstly, our satellite constellation, with more than 3,200 satellites in low Earth orbit, providing enough coverage to reach 95% of the population on the planet and reaching typical latency speeds of up to 30 to 50 milliseconds round trip. Secondly, our customer terminal technology, providing up to 1 gigabit speed download. And then thirdly, our ground infrastructure. We are proud to be manufacturing and installing over 300 gateway stations around the world. Each gateway connects via fiber link directly to AWS infrastructure and from there back to the internet. This enables secure, encrypted links between Kuiper and AWS. Now, this really is just the tip of the iceberg of what the technology can do. Shortly in the presentation, we're going to go much deeper and share the detailed components of each part of our technology. Now, for businesses like yourselves in the room, we are focused on 3 key areas to ensure that we can continue to provide the best outcomes for our customers. Those are delivering high performance, secure global connectivity, and enterprise-grade solutions that businesses can depend upon. And we are ready to support businesses and provide enterprise-grade networking services such as logistics, billing, account management that you'd be very familiar with today if you're an AWS customer, and customer support. But perhaps most importantly, Project Kuiper is backed by Amazon. And for those in the room who are already trusted AWS users, Kuiper is also built on AWS. This gives you peace of mind that your infrastructure, your data, and your security continues to remain our #1 priority. Now, with all that I've shared, I do ask you to think about your business and what you could achieve if you had high-speed connectivity in every place that you operate. I would now like to welcome to the stage Drew Patterson. He's our lead solution architect for APJ Commercial Services. Drew is going to dive deeper into the incredible technology that underpins our Kuiper system. Welcome, Drew.
Good morning, Sol. It's wonderful to be here, and thank you for your time. I thought what we would first do is just set a little bit of context about what makes a low Earth orbit satellite network, like Amazon Project Kuiper, different from perhaps satellite networks that you've used before. Starting with geocentric orbital satellites. So in that geosynchronous orbit, satellites live about 36,000 kilometers above the Earth's surface, pretty far away, and they stay in a stationary fixed location above the Earth and rotate with the Earth. From there, a single satellite can send a beam up to 85,000 kilometers across the Earth, giving an incredibly broad access to the Earth, and it's really good for situations like broadcast television and weather monitoring. And in fact, the first practical use of a geo orbit satellite was the Japan Olympics in the 1960s, broadcasting live the sport to the US citizens. One of the problems and the constraints of having a satellite that far away from the Earth is the distance that you have to cover. A round trip time can typically take anywhere from 650 to 800 milliseconds. It's not what we expect from our internet today, is it? Also, the density at which you can send data into a fixed location is much lower. So geo technologies for data can be quite expensive and prohibitive for everyday businesses and use cases. Medium Earth orbit satellites, they exist about 1,000 to 36,000 kilometers above the Earth. They solved some of the challenges of geo orbit satellites. You can now achieve latencies of around 150 to 250 milliseconds, but it's still not down at around that 30 to 50 milliseconds latency that we experienced from fiber and 5G connectivity. A pretty broadly understood application of a MEO satellite system is for global positioning service. So with our phones, It helps govern us every day when we use maps. Now, when we come to Project Kuiper, Sasha mentioned earlier that we have 3 orbital shells at 590, 610, and 630 kilometers above the Earth. And those first 27 satellites that we launched 2 weeks ago, they're currently sitting at around 450 kilometers above the Earth and are slowly but surely making their final place at 630 kilometers above the Earth right now. They're slowly moving their way up into orbit. The satellites at that polar shell are at an angle of about 51 degrees. And what that means is we will be able to provide coverage very early from the latitudes of 56 degrees north to 56 degrees south. So think about Northern America and Canada all the way down to South America. We will slowly add more satellites to our other shells, and we will alter the angle of inclination so that we can achieve more density around the equator. So as you learn more about us, as you see us launching around the world, you will notice that we'll have coverage at northern and southern latitudes and slowly build and release our general availability towards the equator. Now let's spend a little bit of time understanding what the components are of the Kuiper network and what makes it special. Starting with our terminals. They're pretty simple, right? We like to say here at Project Kuiper that they are delightfully boring devices. And that's on purpose. We deliberately put all of the complexity of our network as much as possible up into the satellites so that these customer terminals, which are phased array antennas, can be as simple as possible. There are no moving motors on these terminals. They're simple to set up. You place them down or mount them onto your rooftop, and they operate in a fixed position. You might put a slight 5-degree tilt on them to encourage rainfall and snow melt to fall off efficiently. But for the most part, they're very simple. Now, a little bit of information about our satellites. When they're operating at that 630-degree height, they're not in a fixed stationary position. They have to travel around the Earth at an incredible speed, up to 25,000 kilometers per hour, which means at any point in time, an antenna above you and I right now might only have a particular satellite in sight for 1 to 3 minutes as it travels over, which means these antennas will be disconnecting and reconnecting to a new satellite to maintain that continuous, reliable coverage quite frequently. How do these antennas achieve that? Well, like I alluded to before, we are leveraging phased array antennas. Imagine a very small antenna about the size of your fingernail, all in a grid pattern. So with our smallest device in the middle, you can imagine that there might be an array of around 100 antennas, and then with the largest one, many more. Don't quote me on that figure of how many small antennas are on that compact terminal. Now, that compact terminal, it's very lightweight, and it's designed for those portability use cases. You can put one in your backpack. A service technician going out to a remote area to investigate why a power line might be a malfunction, or a machinery technician going to a remote construction site to fix a machine. They can easily take that with them in a car. They can easily run that off a battery. And with the low power footprint of this terminal, you could also quite simply run it off of solar power. In the next step up in our sizes, our standard size terminal, it's about the size of a laptop. We expect that most corporate situations and industrial situations where you have a permanent power supply will want to use these because you can achieve speeds of up to 400 megabits per second download. And then at the largest, most performant end of town is our Pro terminals. Pro terminals are about the size, loosely, of a skateboard, as my colleagues like to say. They're a little bit heavier, but they're designed for the most intensive of your data requirements. Think about needing fiber-like speeds at an advanced internet connection at a remote site that you're just commissioning. We can't always wait months or weeks for fiber to be laid. Think about having satellite as a backup path for your primary fiber connection. Think about all of the applications where you could mount it on ships, on remote oil rigs, and wherever those intensive requirements are there. So the terminals, they get our data up to the sky to the satellite, but where does it come down? And the answer is our ground gateways. So ground gateways and the quantity of them that you have, of which we're going to have more than 300, they are the key to achieving low latency. The trip from a terminal up to a satellite down to a ground gateway is just a few milliseconds. The bulk of the millisecond budget, you're around trip time is having enough ground gateways connecting to your Kuiper network board. As you can see here, there's about 4 or 5 parabolic style antennas, and these track and move with motors to provide that connectivity, that resilient connection up to your satellites. Project Kuiper is making significant investments in ground infrastructure to ensure we provide the most performant, resilient, and secure network. Now, perhaps this is my most favorite part of the technology on board of our satellites in the sky. We call them OISLs, or optical inter-satellite links, space lasers. Now, during our proto-flight mission, we were able to leverage and test our space lasers at a distance of 1,000 kilometers. So we had with our Protosat 1 communicating to Protosat 2 using a laser beam over 1,000 kilometers, and we were able to achieve a 100 gigabit connection sustained over time. What that means is we effectively have a space mesh network. Why is that important? What could we possibly do with that? For the physicists in the room, you would know that light, it travels faster in a vacuum of space than it does through glass on ground, fiber optics on ground. It could mean that there are new network paths open to us between countries across long distances where we can shave pretty cool milliseconds off of real-time communication requirements. Secondly, it also means we could provide a fully sovereign and private network between 2 independent countries. Imagine a Korean embassy being in the United States or Australia, wanting to have a completely private network from Australia all the way back to Korea without having to risk traversing any terrestrial network needs. From a practical perspective, it adds a key level of resilience to our network. So our satellites, the radio frequency that we operate, we call the Ka band. Ka bands can be subject to what we call rain fade. Poor weather can degrade the signal quality a little bit and reduce performance. What the optical inter-satellite links allow us to do is, in the event that there is bad weather, which is intercepting strong communication signal between our satellites and the ground gateways, we could potentially hand off traffic to a neighboring satellite, which could then get that data back to ground efficiently. Really exciting stuff. Building satellites, building terminals, building ground gateways, it's hard, but it's not as hard as building a high-performance global backbone network. And we have that with Amazon. So if you're familiar with Prime Video, if you're familiar with AWS today, which I hope you are, you would know that we've built a global backbone network across the world. We have 36 AWS availability regions supported by 114 availability zones. And we have 135 direct connect locations, which are fiber optic meeting points where you can plug your private connectivity, your data centers, into AWS. And thankfully, Kuiper gets to leverage that. It's a huge advantage and something that I'm very proud of as a solution architect to talk about, saying Amazon can guarantee your traffic from your customer terminal all the way into AWS. So how does that all come together? On the left-hand side, you can see the Kuiper antenna. And right there, we supply you an Ethernet port that you can connect to. And imagine it's just Ethernet ports to the internet or your AWS VPC. From there, we encrypt your packet end to end, all the way into the Kuiper network core. Traffic from your customer terminal goes up to a satellite, and usually we'll optimize for latency and packet loss and send your traffic directly down into the Kuiper ground gateway. But if you're a plane operating across the sky or a ship in the middle of the ocean, and there is a lack of access to ground gateways, we can easily use those optical intersatellite links to bridge those gaps. Coming down to the Kuiper gateway, your traffic is still encrypted. And then from the Kuiper ground gateway, we have diverse fiber paths. So 2 independent fiber paths to the AWS network core. From there, you have 2 choices. You can either treat us like an Ethernet port to the internet and have an internet-based service plan, or you can go quickly and seamlessly into your AWS private cloud environment. I'm excited about this because private connectivity, secure, easy connectivity is opening up a lot of conversations with customers. No longer do you necessarily need devices to assist with VPN and additional software-defined WAN technology at your remote location to have a private, secure access into your critical applications and core applications. I'm really excited about the future of connectivity anywhere for anyone. Thank you for your time, and let me hand back to Sasha for closing remarks.
Thank you, Drew. Wow. I'm very, very excited about the technology that is packed into the system. I hope that gave you a really good insight into the power of what Project Kuiper can do. Now, I'm really excited also about being here in the region and being able to drive outcomes for our customers and our communities. The launch of the first 27 satellites that you saw earlier is really just the beginning. We've now secured a record-breaking 80 launches to continue to build out the constellation in the coming months. And we're very excited that each of you will be along with us on that journey. Our upcoming goals are certainly ambitious, but I'm inspired, along with the Kuiper team here in the region, in knowing that together with Amazon and AWS, that we have the infrastructure and the resources to deliver global impact and make a real difference to all businesses and all people around the world. Now, I want to say thank you to each of you for joining our session and learning more about Kuiper today. The Kuiper team will be here today and tomorrow, and so we would welcome a conversation. If you'd like to come and find us after the event, please do so. We'll be happy to share more information. Thank you so much.